is the first. What are the four factors? Concentration. Lagi?
Temperature.
Temperature.
Use of catalyst.
Next is the physical state. And lastly is the catalyst. Okay. So when we talk about the rate law, okay, it will express okay how rate being affected by the first two factors, which are the concentration and the temperature. Okay, that is why if you look at to the textbook just now, it said that the rate law express the rate as a function of the concentration and the temperature. And then the rate law is based on the experiment. Okay, the rate law for any reaction is actually based on the experimental data that we get. Okay, so we cannot make any hypothesis about what is the rate law. It has to be based on the experimental data. Okay, so if let's say we have a reaction of A, I'm using the same equation as in the textbook. Okay, if we have a reaction of A plus B produce C plus D, okay, the rate law of this reaction will be rate equal to concentration of the first reactant, which is A. Before that, K is the rate constant. Rate is equal to K A, concentration of the first reactant, power of M, B, power of N. Okay, so in the rate law, okay, it just involves the reactants. Okay, no products come out in the rate law. Okay, so let's look at to the components in this rate law. Rate, of course lah. Okay, it is the how fast the reaction occur. K is the rate constant. Okay, and then A in bracket, that is the concentration of A. B in bracket is the concentration of B. Okay, M, what is M? This M is the reaction order of A. Okay, N is the reaction order of B. Okay, M is the order for A, and then N is the order for B. So the value of the rate constant, the value of the order, M and N value, okay, only can be determined by the experiment. Okay, but what is the meaning of the reaction order? Look at your textbook. Highlighted there, reaction order. So the reaction order define how the rate is affected by the reactant's concentration. Okay, the value of M, okay, will determine how, when we change the concentration of A, will give effect to the rate. Okay, the value of N will tell us how, if we change the concentration of B, it will give effect to the rate of a reaction. Okay, so that is the reaction order. How to get the value? Okay, so I want you to look at to the table 16.1 in the textbook, page 706. Okay, how to determine the rate law of this reaction? Okay, so this is a reaction of A plus B produce C. A plus 2B, if you look at to the textbook, it is a reaction of A plus 2B produce C plus D. Okay, so what they did is they ran several experiments. Okay, when they changed the concentration of both reactant A and B. Okay, so look at to the data that we have in the first set of experiment, the first series of the experiment. Okay, they are using the concentration of A 2.5, okay, exponent negative 2, and then the concentration of B is 3 exponent negative 2 molar, both, and they measured the rate of this reaction when their concentration are this is 1.75 exponent negative 3 mole per liter per second. This is the rate if the concentration of A and B is this. Okay, and then in the second experiment, they change the concentration of A become 5 exponent negative 2. Concentration of B remain 3 exponent negative 2. Then they measure the rate of this reaction with this certain concentration is now 3.5 exponent negative 3. And then in the experiment, the third series, experiment 3, they change the concentration of A to 2.5 and then B to 6 exponent negative 2, and then they measure the rate is 3.5 exponent negative 3. So they are actually playing around with the concentration of all reactants that they have. So finally, from the data that they got, they can determine what is the rate law of the reaction, in which the rate law is rate equal to K A power of M B power of N. The value of M and N is not related to the, it does not related to the stoichiometric coefficient here. Tak ada kaitan pun. Okay, the value of M and N must be calculated through the, must be got from the calculation. Okay, so how to calculate the value of M and N? Okay, so if you want to know what is the order for A, okay, if you want to know what is the M value or what is the order for A, we have to choose two series of experiment with the same concentration of B. Okay, nak tahu berapa M value, what is the order for A, we have to choose two series of experiment with the same concentration of B. So, 1, 2, 3, 4, okay, concentration of B that are the same is 1 and 2 or 3 and 4. Kena pilih dua eksperimen saja. So, you can choose either 1 and 2 or you can choose 3 and 4. Okay, so let's use 1 and 2. Okay, so let's use the data in the experiment 1 and 2. Use the concentration of B here, A, and also its rate. Okay, so this is the basic of the rate law. Okay, rate is equal to, let me rewrite. Rate is equal to K A power of M B power of N. So we want to determine M first. So we choose just now experiment 1 and 2. So please refer to your textbook. Okay, so in the experiment 1 and 2, normally I'll choose the one that have a higher rate to be the numerator. So that it will be rate in the experiment 2 over rate in the experiment 1 equal to K concentration of A power of M in the experiment 2, concentration of B power of N in the experiment 2 over K concentration of A power of M in the experiment 1, concentration of B power of N in the experiment 1. Okay, so just plug in the value. So rate 2 is 3.5 exponent negative 2. I change mole per liter to molar per second. Mole per liter is molar. Okay, because the unit is too long. And then rate 1 is 1.75 exponent negative 2 molar per second is equal to the rate constant that we don't know. Okay, but we know the concentration of A in the experiment 2. Okay, this one, the concentration of A in the experiment 2 is 5 exponent negative 2. So negative, yes, negative 2. The rate is negative 3. Okay, power of M that we don't know. Then the concentration of B in the experiment 2 is 3.0 exponent negative 2 power of N. Okay, and then in the experiment 1, rate 1, K, A, experiment 1, B, experiment 1, plug in the value. We don't know what is the rate constant, but we know the K is the same. Okay, and then concentration of A in the experiment 1 is 2.5 exponent negative 2 power of M. Concentration of B in experiment 1 is 3.0 exponent negative 2 power of N. Okay, so we can cut K with K because we know that they are the same. Okay, 3 exponent negative 2 power of N, we can cut it with this because of the value are the same. Okay, so what we need to calculate is just the rate 2 over rate 1. Okay, so 3.5 over 1.75, obviously that it is equal to 2. Okay, so it is equal to 2 here, equal to 5.0 over 2.5. Okay, exponent negative 2, exponent negative 2, power of M. Okay, so 5 over 2.5 will be 2, power of M. Okay, so obviously that M 2 power of 1 is equal to 2 power of M. So M is equal to 1. Okay, so the order for the A is first order. Okay, so we have to make conclusion. So it is first order for A. Okay. There are 3 orders that we covered in our syllabus. First order, second order and zero order. Zero, first dengan second je yang kita cover dalam syllabus. Sebenarnya kita ada banyak lagi order. Okay, but what we cover is only zero, first and second. Okay, and then now we know that M is 1. Okay, this is the first order. A is the first order. Because the value of M that we have calculated is 1. Now we want to determine what is the N value. Okay, what is the order for B? So it is easier for us to choose 2 experiments with the same concentration of A. Okay, we choose 2 experiments with the same concentration of A to know what is the order for B. Okay, so look at back to the data that we have in the table 16.1, page 706. Which 2 experiments that have the same concentration of A? Putri Sabrina. Putri Sabrina? Muhammad Haris. Muhammad Haris bin Ahmad Mumtaz.
Yes, madam.
Which 2 experiments that have the same concentration of A?
Experiment 1 and 3.
Experiment 1 and 3 or 2
Or
and 4,
3,
right?
3 and 5.
Oh, ada eksperimen sampai 5 ke? Saya ada sampai 4 je.
Oh, silap page. Experiment 2 and experiment 1 and 3 and or 2 or 4.
Okay. Okay, you can choose any 2. Okay, let's choose 1 and 3. Okay, if we choose 1 and 3, okay, to determine what is the N value, okay, so just repeat the same step. Okay, look at to the rate. Which one that have a higher rate? 3 and 1. So the rate 3 is higher than rate 1. Actually, you can choose 1 over 3. Okay, tapi kalau saya personally, I'll choose the greater value over the smaller one. Okay, anyone will leads to the same answer. Okay, so I choose rate 3 over rate 1. It is equal to K, concentration of A, power of 1, since that we have calculated the M value. In the experiment 3, concentration of B, power of N in the experiment 3, over K, concentration of A, power of 1 in the experiment 1, concentration of B, power of 1 in the experiment 1. Just plug in the value. Rate 3 is equal to 3.5, negative 3 molar per second over 1 point. Rate 1 is 1.75 exponent negative 3 molar per second equal to K, concentration of A in the experiment 3 is 2.5 exponent negative 2 molar, power of 1, concentration of B is 6.0 exponent negative 2 molar power of N over K, concentration of A in the experiment 1 is 2.5 exponent negative 2 molar power of 1, and then concentration of B is 3.0 exponent negative 2 molar power of N. Okay, so now we can cut K, the rate constant with the rate constant, 2.5 exponent negative 2 power of 1 with this because of the same value. Okay, the unit with the unit. Okay, what's left is just 3.5 over 1.75. It is equal to 2 equal to 6 exponent negative 2 over 3 exponent negative 2 power of N. So it is 6 over 3 is 2 as well, 2 power of N. So finally, we know that N is equal to 1. Okay, it is easy for this example because they are obvious. 2 is equal to 2 power of N, so that we know that N is equal to 1. Okay, sometimes, okay, we got a fraction or decimal place number, okay, decimal point. So that you have to use your calculator, you have to calculate log, anti-log. Okay, anti-log to got what is this power value. So in this case, N is equal to 1, and then we have to make the conclusion. It is compulsory. Okay, so it is first order with respect to B, ataupun it is first order for B. Boleh juga, but the conclusion is compulsory. Okay, so when you have the value of the N and M, then you can rewrite your rate law. It is rate equal to K, A power of 1, B power of 1. Okay. Before that, the value of M plus N. Okay, M is the reaction order of A. N is the reaction order for B. So what is M plus N? This is what we call as the overall order. Okay, so since that M is 1, N is 1, so that it is equal to 2, means that the overall order of this reaction A and B is second order. Okay, so the overall order for this reaction is 1 plus 1, so it is second order. Okay, So after we have the order for each reactant, okay, it is not necessarily that the reaction occur with two reactants. Okay, we can have more than two reactants, 3, 4, 5. Okay, depends on the reaction. Okay, we also can, if let's say we have 3 reactants, so that the rate law will be rate equal to K A power of M, B power of N, C power of O, D power of P, for example. Okay, but if we have only 3 reactants, A, B, C, then the overall order later will be M plus N plus O value. Then we will get the overall order. Okay, and then come back to this reaction. Now we have the order. We can calculate the rate constant, the K value. Okay, so how to calculate the K value? Just choose any one experiment that we have in the table. Okay, and then we make K as a subject to calculate K. Okay, since that we want to know what is the K value, make it as a subject. So K is equal to, okay, we can choose any experiment that we want. Okay, since that we haven't used experiment 4 first. So let's use the data from experiment 4. It should be the same. You can use experiment 1, 2, 3 or 4 data. Okay, so let's use experiment 4. Rate in the experiment 4 over K concentration of A power of 1 in the experiment 4, concentration of B power of 1 in the experiment 4. So that the K will be equal to rate in experiment 4 is 7.0 exponent negative 3 mole per liter per second or molar per second over with the K tak ada K lah dekat sini. Okay, over with the concentration of A in the experiment 4 is 5.0 exponent negative 2 mole per liter power of 1, and then concentration of B in experiment 4 is 6.0 exponent negative 2 mole per liter power of 1. Okay, actually we just plug in the value. This is from the data, concentration from the data in the experiment 4. Same goes with the concentration of B. Okay, just press the calculator. Okay, then we will get the K value 2.33. What is the unit?
S negative 1.
Okay, the unit is S negative 1 ke? This is mole per liter, cut with 1 mole per liter, so that we still have this left. It will be, the overall order is the second order, so that it will be liter per mole per second. Okay, so when we calculate the rate constant, the value and also the unit is insisted. Okay, they have to be correct. Okay, different overall order will lead to different unit of the rate constant. Okay, this is the rate constant unit for the overall order second. Okay, for the second order. Okay, dia punya unit of the rate constant is depends on the overall order lah. Dia tak ikut satu-satu ni. Okay, since that this is the second order reaction, so that the unit of the rate constant is the concentration negative 1. Okay, it is a concentration negative 1. Kalau molar is the concentration unit, it will be molar negative 1. Okay, and then second or time negative 1. Okay, time can be in second, minute, hour, years, okay, and so on. Okay, it is not necessarily that the time must be in second, not necessarily. If we have a slow reaction, then we don't convert it to second. Okay, if let's say we have a very slow reaction, okay, we don't need to convert it to second, unless the question asks us to do so. Okay, I told you that the rate law is actually it is showing the effect of the changes in the concentration and also the temperature. Okay, the factors, the temperature factors and also the concentration factor. What we have calculated here, okay, is when we change the concentration of the reactants. Okay, when we change the concentration, it gives effect to the rate. Okay, since that concentration of the reactants is one of the factors that we can control, then it can lead to the different rate. The second one is the temperature. Okay, when we change the temperature, then what will happen is the K value will change as well. Okay, when the temperature is increased, then the rate constant will increase as well. Okay, that is why when we run the experiment, okay, on this, we run the experiment on this kinetic, okay, normally the four or the five series of experiment macam kita tengok tadi tu, experiment 1, 2, 3, 4 tu, we have to make sure that the reaction is occur at the constant temperature. Okay, we have to make sure that the reaction occur at the constant temperature, because if we want to see the effect of the concentration only to the rate of a reaction, we don't want the K value to be changed. Okay, the K value will be the same if the concentration change. But if the temperature change, then the K value will change as well. So if we just want to see the effect of the concentration to the rate of a reaction, so we have to make sure the temperature of all series of the experiment to be constant. If it is happen at 27 degrees C, all experiment 1, experiment 2, experiment 3, experiment 4 must occur at 27 degrees C as well. Okay, so that it will give no effect to the K, as the K is also directly proportional to the rate. Okay, when K change, rate also change. So if we want to make sure that, if we want to see the effect of the temperature, okay, so we make the concentration constant, we just change the temperature so that the K change. But if we want to see the effect of the concentration, we have to make sure that the temperature constant, so the K also constant. Okay, so please please remember that point.